Hey everyone, before we start the video, I just wanted to take a moment to let you all know about how to change some of their settings on YouTube. If you need captions or if you need to slow the video speed down, here are some instructions on how to do that. You can pause the video now and go ahead and change your settings as you need. Otherwise, just continue on. Thank you. Hey everyone, welcome to this regression analysis video. In this upcoming module, we're going to be using regression analysis to analyze our data and figure out what kind of conclusions we can draw from our data. The video itself is recorded by Elizabeth Farrell, who's my colleague and an Eddy community member. She does a really good job at explaining what regression analysis is and how we can use it. This video is designed for you to take your pre-lab quiz about regression while watching this video. So I encourage you to have the quiz open while you watch this video, and then you can take the pauses that we've incorporated within the video to answer a few questions and then come back and continue watching the video. Thanks and enjoy.
This is Rita. Rita owns Rita's Ice Cream Shop. She's been tracking temperature, humidity, and rainfall to see if any of those variables might be related to her ice cream sales. I want you to take a moment and think about what kind of relationship there might be between ice cream sales and temperature. What about ice cream sales and humidity, or ice cream sales and rainfall?
All right, pause the video here and answer the first 3 quiz questions. When you're done, you can come on back and continue watching the video.
Some of you might have hypothesized that temperature has a little something to do with whether or not she's going to sell any ice cream. It serves to reason that during cold months of the year, ice cream sales might be a little bit lower than hotter times of the year. Let's go take a look at some of Rita's data.
Pause the video and answer your next 2 quiz questions. What's being plotted here, and what are the independent and dependent variables?
What can we understand from these 2 plots, and how might we be able to investigate this data further? Take a moment to describe the axis, the major trends, any inflection points or points of transition where the slope goes from positive to negative, any outliers, points on the graph that really don't seem to fall into the general trend of the data that we see. What's the general pattern that you're seeing in each of these graphs?
Please pause the video here and answer the next 2 quiz questions. When you're done, come on back.
Now that you've thought about the general pattern in both of these sets of data, what kind of relationship do you see between temperature and sales? How can we quantify this in a single illustration? The answer is regression. Here's another way for us to look at the data so we can see how sales and temperature might be related. It looks like they are, but how can we describe that in a quantitative way? 2 curvy graphs produce this straight pattern. So we say that those 2 sets of data varied together. They had a common x-axis, months of the year, and followed a similar trend. It's important to keep in mind that not all relationships can be described using linear regression. We can easily see a line forming for this data set, but not necessarily for the last data set.
Pause the video here and go ahead and answer the next quiz question. When you're done, come on back.
We can make a general statement that it seems that when temperatures are high, sales are high. But how can we quantify this? By fitting a trend line to Rita's data and adding an equation. Remember back from high school algebra that x is the independent variable, y is the dependent variable, m is the slope of the line, and b is the y-intercept. So when we add the equation to Rita's trend line, we get y equals 3.8x minus 51. The slope indicates the relationship between those 2 variables. In this case, degrees Celsius versus ice cream cones.
Pause the video here and go ahead and answer the next quiz question. When you're done, come on back.
It's important to note that the regression line is an average. You can't really sell 3.8 ice cream cones. So we added a trend line to our data. We added an equation for that trend line, and that equation can start to explain the relationship between the x and y axis. R squared is the coefficient of determination. The R squared metric tells us how well the data fits the model, and that R squared value can vary from 0 to 1. When you have an R squared value of 0, your data doesn't fit the model at all. When the R squared value is 1, the data fits the model perfectly. In other words, R squared is the proportion of variation that explained by the model. Or even simpler, how close those data points are to the trend line. A really small R squared or an R squared of 0 shows that those data points are all over the place and really far, right? 0% of those data points are close to the line. As you approach 1, 100% of your data fits that model perfectly when you have an R squared of 1. If you see an R squared of 1, you should look more closely at your data. Many times when we collect data, it's not that clean, and there will be a degree of variability. Those data points are not so close to the best fit line. The R squared coefficient shows us whether the model we've chosen, or the equation for that trend line, explains what's going on in the data. With an R squared of 0.23, the model doesn't tell us very much. With an R squared of 0.99, our model explains pretty much entirely what's going on. So what's causing these differences in R squared?
Pause the video here and go ahead and answer the next quiz question. When you're done, come on back.
The R squared value for Rita's data is 64. Remember that when R squared is 0, 0% of the variation can be explained by that simple linear model. When the R squared is 99, 99% of that variation can be explained by our linear model. So Rita's R squared value is 64, meaning that 64% of that variation can be explained by the linear model. And 36% of those ice cream cone sales are not directly related to temperature.
Pause the video here and go ahead and answer the next quiz question. When you're done, come on back.
It looks like it was worth it for Rita to collect that data. She was able to quantify the relationship between sales and temperature. Generally, sales tend to increase on hotter days. We can use the equation for Rita's trend line with 64% certainty to try to predict the number of ice cream cone sales based on the temperature.
All right, everyone, that's it for this video. So you can go ahead and answer the last questions on your quiz, and then you can move on to the next pre-lab activity.